Hey students of East High and YouTube, it's Miss Fishman. I'm back coming at you live with 2 videos. I keep saying that, but it's still not live. We're going to be doing graphing inequalities. It's super similar to graphing equations. There's just 2 major differences, and we're going to go over them. First, I want to show you, we have this beautiful line, y equals 2x plus 1. I want to show you visually what it's going to look like, right? This is an equation. Then an inequality just looks like this. It might look a little scary, but it's exactly the same. We're just adding 2 pieces. I wonder if you can guess what those pieces are because I kind of spoiled it. But let's carry on. We're going to go through these notes, and then in the other video I'm going to release, it's going to be examples that I'm going to work through. What I would recommend doing is following along with this video, taking notes, maybe watching it 2 times if you feel like I'm moving too quickly or you need to see it again, and then moving on to examples. Once you've completed the examples, I recommend moving on to the Google form that we're going to give you. There might be a Delta Math, spoiler alert. So let's get started. To graph a linear inequality, step 1 is to use inverse operations to write the inequality in slope-intercept form. If it is not already in that form, I am writing it out for you so you don't have to see my ugly handwriting because we know how that is. And remember, slope-intercept form is y equals mx plus b. Our m tells us our slope, our b tells us our y-intercept. Step 2 is to use the y-intercept and slope to graph your line. Step 1 and 2, nothing new. What is new is a solid and a dashed line, also known as a dotted line. If your inequality is greater than, let me draw with touch. If your inequality is greater than or equal to, or less than or equal to, you will have a solid line because equal to means included, so it's solid. If your line is dashed or dotted, it'll be greater than or less than. You don't have that or equal to, which means it's not included. Okay, so that's why it's dotted. Blah, I kept wanting to say dashed. So let's scroll down to our examples. We'll get to step 3 in a second, but let's start here. So example 1, 3x plus 2y is greater than or equal to 2. That's not in slope-intercept form. So let's start by doing that. We can treat that greater than or equal to sign basically as an equal sign and just rip. Now let's get y by itself. 3x, and you get 2y is greater than or equal to, don't forget that, negative 3x plus 2. The furthest thing, and on the same side as y now, is that 2. They're next to each other, so we're going to divide, and you get y is greater than or equal to negative 3/2 x plus 1. So now we're going to do what we normally do. We're going to start with our y-intercept. We're going to put a 1 there. Excuse me, a dot on that positive 1. Then we have our rise, negative 3, over our run, positive 2. So remember, rise over run, y over x. So we're going to go down. Let me use this color. We're going to go down because it's a negative 3. 1, 2, 3. Then we're going to go to the right because it's a positive 2. 1, 2. Let me put my little dot there, and let me erase this for clarity. So, based on the slope, sorry if it's not perfect. My pen is like a little thick, so it can be hard to see how I'm drawing. But based on the slope and the y-intercept, we draw a line. It's beautiful, mostly, even though it's kind of annoying me, but that's okay. Now we're going to draw our line. We have greater than or equal to, right? If it'll let me actually draw, this is annoying. There we go. Greater than or equal to. So let's scroll up and check. Is this going to be solid or dashed? Solid, right? I'm going to draw it with my hand, and it's going to look really ugly, and you guys are not going to judge me, so we're just going to go for it. That's terrible. I actually have to redo that. That's not okay. Okay. Not as bad. Okay. So it basically just looks like a regular y equals. We'll do the next step that'll make it different, but for right now, we're good here. Let's move on to the second example. Y is less than 2x minus 4. It's already in slope-intercept form. It's got that beautiful y equals mx plus b. So let's start by isolating that y-intercept. That's a negative 4, so we're going to drop it at the y-axis, and we have a negative 4. Maybe it's because I'm not doing it the way it wants me to do it. That's terrible. Ugh. So, if it would ever let me draw it, there we go. It's a terrible little dot, but that's okay. We're all beautiful in our own way. Now we know our slope is 2, which means it's 2 over 1. So it's a positive 2 over a positive 1. That means we're going to bunny hop up 1, 2. We're going to bunny hop to the right 1. And we are going to put our dot there if it'll let me this time. Maybe. Hello, friend. So, you want to double check that you're doing this. I'd recommend following along with this example while I struggle. There we go. That's the best it's going to look. That's what you guys get. So, y is less than 2x minus 4. Before you go drawing your solid line through it, let's double check. A dotted line is greater than or less than. This is less than. So when we draw our line, we're not just going to zoom all the way through like we did for that first example. We're actually going to draw it like this, as like little dashes or little dots with holes in between, because it's not or equal to, right? So we're not including the line as something that's an answer. So basically, when it has that line underneath, draw it solid. When it doesn't, draw it dotted, right? You might be thinking, oh my gosh, is that all it is? So easy. I know, it's so easy, but there's actually one more step. Still easy, but just to warn you. Step 3 is asking you, oh, let me type again so you don't have to see my bad handwriting, is to shade either above the line or below the line. Now, this only works if your line is in slope intercept form. This will only work if your line is in slope intercept form, okay? Otherwise, you're going to have to use a test point, and I'll go over what that means with the first one in a minute. But to shade above, you're looking for greater than or equal to. For shading below the line, you're going to be looking for less than or equal to, okay? So if you see anything greater than, it's going above. You see anything less than, it's going below, right? Think about less than is below you, or greater than, oh my gosh, it's greater than, it's above, right? So let's finish our inequality now. We did the first step, which is graphing the line and deciding if it's solid or dashed. Now the final part is deciding how to shade it. Well, this is y is greater than, right? Which means we're going to shade above. What color should I use? I'm going to use, oh, this is kind of nice. I'm going to use my pretty blue color because I really like this color. Above. Just go crazy. Shade however you like. So pretty. And guess what? You're done. That was it. Now, if we wanted to solve it, like it's in this ugly form, if we wanted to solve it and not change the form, that'll be very difficult to graph. But if you just want to do a test point, I always use the point 0, 0. If the line is not going through 0, 0, you can use it, and I recommend it because it's easier. So we're using this 0, 0 as a test point. You don't have to do this. I'm doing this just to prove to you it's correct. So y is going to be 0, right, because this is our x. I'm going to change the color, actually, so you don't get confused. I'm going to make x green, that really pretty forested green. I'm going to make y. So 0 is greater than or equal to 3 halves, negative 3 halves, times x plus 1. 0 is greater than, negative 3 halves times 0 is 0 plus 1. 0 is greater than or equal to 1. Is 0 greater than 1? No, it's less than, right? Because having $0 means you have less money than someone who has $1, right? So our test point is false, so we would shade on the other side, which is what we did. So we're amazing. I'm not going to do that on the second one just because you've worked it through as an example now and you don't have to do it because you're going to be getting it in the linear equation anyway. So let's shade. This one's even easier, right? Y is less than 2x minus 4. Let's check. Less than means below. So I'm going to use green because I like that and just shade below. And there you have it. Not too scary. Like I said, it's basically just graphing an equation. You just have to add dotted or dashed and then shading, dotted or solid and then shading above or below. I'm going to come back in the next video. We're going to work through a few examples together. What I recommend doing is getting out a piece of scratch paper and then working through these examples with me, okay? I'll see you guys in the next video. Bye!